Hello class, welcome to a new video. So in this video we are going to be going through some of these properties of the residuals. Okay, I hope you know what are residuals. Remember we have remember we have learned about the plane of regression. Suppose you consider the plane of regression of x1 on x2 and x3, then it is given by x1 equal to b12.3x2 plus b13.2x3. Then the residual of this equation of the plane of regression will be given by x1.23, which is equal to x1 minus 1 b12.3x2 minus b13.2x3. So this is known as your residual. Okay, it's just the difference, okay, given like this. And take a look at the suffix here. Here you have 1 and then you have a point and then you have 2, 3. So this means it is the residual of x1 on x2 and x3. The subscript before the point is known as the primary subscripts, and the subscripts after the point is known as the secondary subscripts. Okay, before the point it is the primary subscripts. So let us go one by one these different properties. Okay, property number 1 of these residuals. Suppose you have the sum of these two residuals x2 and x1.23. If you have the sum of the product of these two residuals, this will be equal to 0. Okay, this is one property. This is because this subscript here 2 is present in the secondary subscript of this next residual. Okay, if it is present in the secondary subscript, then the sum of the product is always equal to 0. Okay, in the same way, suppose you have the sum of the product of x3 into x1.23. Here also this 3 is present in the secondary subscript of the second residual, then this sum of the product will also be equal to 0. Okay, and in general this property can be given like this: summation xi into x1.23 so on up to n. This will be equal to 0 where I goes from 2, 3 up to n. That means I can take any number from 2 up to n. Okay, so this is the property number 1 of residuals. The statement I'm not going to read out. I'm just going to show you in this way, in this simplified way, so that you can understand. Now let us move on to the property number 2. Property number 2. Okay, so property number 2, suppose you want to find the sum of the product of these two residuals, x1.2 into x1.23. Okay, so you replace here this x1.2. x1.2, it simply means the residual of x1 on x2 only. So that means the regression line will be given by what? x1 equal to b1.2 into x2, not dot 2, sorry, it's only b12x2. So that means the residual x1.2 will simply be x1 minus b12x2. So you simply replace this here. What will you have? So you will have summation x minus b12 x2 into x1.23. Okay, x1.23. Now you distribute this inside the bracket. What will you have? So if you distribute it inside the bracket, you will have this summation of x1.2 into x1.23 to be equal to summation x1.23 minus b12 is constant, it comes out of the summation sign, then summation x2 x1.23. But we know from property number one that this term here will be equal to 0 because this 2 is present in the secondary subscript of the residual x1.23. Okay, so that means the second term will vanish, it will be equal to 0, and you'll simply be left with summation x1 into x1.23. Okay, so this is the second property. Here you can just say using property number 1. Okay, using property number 1. So that means if you want to find the sum of the product of these two residuals, okay, the primary subscripts, they are same, then it is same as finding the product of this. Okay, now in the same way, suppose you want to find the sum of the square of the residual. Suppose sum of x1.23 square. So this you can write as the sum of x1.23 into x1.23. Okay, and then this will be equal to, so you replace only one value of x1.23. You already know this one. This will be x1 minus b12.3x2 minus b13.2x3 into x1.23. Okay, so you substitute here, you multiply inside the bracket, so you have x1.23 minus b12.3 summation x2 x1.23 minus b13.2 summation x3 x1.23. Okay, so here you can see that this second term and this third term, they will vanish, they will be equal to 0. Okay, using property number 1, and eventually you will be left only with this first term, summation x1 x1.23. Okay, so this is the property of property number 2. Okay, I hope it is clear. They will all vanish. Okay, the property number 1 is very important. From property number 1 we can get this result. Okay, and okay, another one, suppose you want to find the sum of the product of x1.34 up to n into x2.34 up to n. Here the secondary subscripts are same, but the primary subscripts are different. So in order to solve this, you substitute in the same way you substitute only the value of the first residual. This will be x1 minus b13.4 up to n of x3, okay, minus b14 b14.35 up to n of x4, and so on. Okay, till the last term minus b1 n dot 34 up to n minus 1 of xn. Okay, and the second residual remain the same, 2, 3, 4 up to n. So here, if you distribute inside this term inside the bracket, you will see that if you multiply this with this, it will vanish because this 3 is in the secondary subscript. If you multiply this with this 4 is in the secondary subscript, so it'll vanish, and so on. So every term will remain 0 except the first term, and you'll eventually be left with only summation x1 into x2 dot 2.34 up to n using property number 1. Okay, I hope this is clear. If you try and practice by yourself, this is not hard at all. It's very easy. So let us move on to the next property, property number 3. Property number 3. Okay, the property number 3, it states that the sum of the product of two residuals is 0 if all the subscripts, primary and secondary, of the one occur among the secondary subscripts of the other. So we will understand this by an example. Suppose you want to find the sum of the product of these two residuals, summation x1.2 into x3.12. Okay. So here this primary and secondary subscript of the first residual is present in the secondary subscript of the second residual. Okay. So here this is supposed to be 0. We can prove this in the same way, in the same manner, like how we have done before. Just substitute here. This will be what? x1 minus b12 x2 into x3.12. So if you multiply, you have summation x1 x3.12 minus b12 summation x2 into x3.12. Okay, so we see here this 1, it lies in the secondary subscript. This 2 also, it lies in the secondary subscript. So here you'll have 0 minus 0 using property number 1. Okay, and hence the sum of the product of these two residuals is equal to 0. Okay, I hope this is clear. You see, so you have to understand properly that first property of the residual, the property number 1, and from that property number 1 you can prove property number 2, property number 3. Okay. So again, suppose you want to find the sum of the product of these two residuals, summation x.2.3 up to n into x1.23 up to n. So you substitute only the first residual. This will be x2 minus b23 dot 4 dot up to n x3 minus b24 dot 3 5 dot up to n x4, so on till minus x. Not x, sorry. b2n dot 3 4 dot up till n minus 1 xn. Okay, and then here you multiply x1 dot 2 3 dot up to n. So if you distribute this x1 dot 2 3 up to n inside, you will see that if you multiply with this first term, this 2 lies here in the secondary subscript. This 3 also lies here in the secondary subscript. This 4 also will lie here. This n also will lie here. So this, everything will be 0, minus 0, so on, minus 0. And hence this will be equal to 0. Here you are using property number 1. Okay. So hence, even this sum of this product of these two residuals will be equal to 0. I hope this is clear. So remember, the property which is very important, the property which is very important is property number 1. So you have to keep in mind property number 1. This is very, very important, okay? Where if you have the sum of the product of x2, suppose, then x2.13, and if this subscript lies in the secondary subscript, it will always be equal to 0. In the same way, this 3 lies in the secondary subscript, so this will also be equal to 0. So you remember this property number 1. It is very important. From property number 1, you are able to get property number 2 and property number 3. Okay, now after we have learned this property of these residuals, we will try to find the variance of residuals. The variance of the residuals. Okay, so in order to do this, let us consider the plane of regression. Let us consider the plane of regression of x1 on x2, x3, so on till xn. Okay, so let us consider this plane of regression, and this equation of the plane of regression will be given by what? It will be given by x1 equal to b12.34 up to n x2 plus b13.24 up to n x3 plus so on. The last term will be b1n.23 up to n minus 1 xn. Okay, so here, since all the xi's are measured from their respective means, remember way before in the videos when I started multiple correlation, I've said that all the xi's are measured from their respective means. So which means that the expectation of all these xi's will be equal to 0. Okay, where I goes from 1 to up to n, because they are measured from the respective means. So if these are all equal to 0, then that means even the expectation of the residual x1.23 up to n, even this will be equal to 0. Okay, I hope this is clear. So now let us find the variance of the residual. So the variance of the residual will be denoted by sigma square of 1.23 up to n. Okay, so this will be, so you take the original formula, summation of x1.23 up to n minus the expectation of this. This is the formula of variance only. There's nothing new here. Up to n whole thing square. So we already know that this is equal to 0. So that means this is just 1 by n summation x1.23 up to n square. Okay. And using those property of residuals, we know that using property number 2, we have already learned about property number 2. This will be equal to what? This will be equal to summation x1 into x1.23 up to n. Okay, using property number 2 of residuals. Okay, so after using this property, now you substitute here the values. What will be this x1.23? This is equal to x1 minus b12.3 up to n, x2 minus b13.2 up to n, x3, and so on. So you substitute these values here. What will you get? So our sigma square 1.23 up to n, this will be 1 by capital N summation x1 into x1 minus b12.34 up to n x2, then minus b13.2 up to n x3, then so on, minus b1n dot 2 3 up to n minus 1 xn. Okay, so now you distribute this 1 by n summation x1 inside the bracket. What will you have? So this first term will be 1 by n summation x1 square, and that is nothing but sigma 1 square. Okay, the second term will be minus b12.34 up to n 1 by n summation x1 x2, that will be r12 sigma 1 sigma 2. Remember, from the plane of regression, I've already shown you how we have gotten this. Okay, remember, summation 1 by n summation xi xj is equal to rij sigma I sigma j. I hope you still remember. So you substitute in this way. Okay, next term will be what? Next term will be minus b13.2 up to n, then r13 sigma 1 sigma 3, then so on. Last term will be minus b1n dot 2 3 up to n minus 1 r1n sigma 1 sigma n. Okay, so what you do is you just take the sigma 1 square to the left hand side. So here you take sigma 1 square to the left hand side. What will you have? You will have sigma 1 dot 2 3 up to n square minus sigma 1 square. So you, in the right hand side, you remain only these regression coefficients b12 3 4 up to n, r12 sigma 1 sigma 2, then okay, you remove, oh sorry, here you remove all the negative sign. That means first this will be sigma 1 square minus sigma 1 dot 2 3 up to n square. So therefore the right hand side will all be positive. Okay, so this will be b12 3 up to n, r12 sigma 1 sigma 2 plus b13 dot 2 4 up to n, r13 sigma 1 sigma 3. Okay, and so on. Okay, till the last term, b1n dot 2 3 up to n minus 1 r1n sigma 1 sigma n. Okay, so after you have obtained this equation, now you have to eliminate all the b terms. Okay, you eliminate all the b terms and you will have this determinant as follows. Just like how we have done in plane of regression, you eliminate all the b terms. Okay, then you will have the determinant like this: sigma 1 square minus sigma 1 square 0.23 up to n, then r12 sigma 1 sigma 2, and so on, r1n sigma 1 sigma n. Then here you will have r12 sigma 1 sigma 2 Then here you'll have sigma 2 square, so on till r2n sigma 2 sigma n, and so on r1n sigma 1 sigma n, and then r2n sigma 2 sigma n, so on sigma n square. Okay, so you'll have this determinant like this, and this will be equal to 0. Okay, so now you have to perform row operations and column operations. Okay, on this determinant you have to perform row operations. So you divide the first row by sigma 1, you divide the first row by sigma 1, second row by sigma 2, and so on. And then after you perform the row operations, you perform column operations. You divide column 1 by sigma 1 like this. You divide column 2 by sigma 2. Okay, so if you do this step by step respectively, then you will obtain this determinant like this. This first point here will be 1 minus sigma 1.23 up to n divided by sigma 1 square. Then the next point will be only r12 up till r1n. Then here will be r12 1 up till r2n, and so on. Here you'll have r1n, r2n, 1. So I'm not showing you all the steps. You can just do it by yourself. This is not hard at all. You just perform by yourself those row operations and column operations. Then you'll get in this way. Okay, you'll get in this way. So now this determinant is the same thing as writing here plus 0 and so on, plus 0 like that. Okay, it's the same thing as writing like that, and we can split this. The main objective is to split this term here, okay, into two determinants. So what you will have is, you will have 1 r1 r12 up to r1n, then r12 again 1 r2n, then r1n r2n up to 1. So this will be one determinant minus, so now here you write that other term, sigma 1.23n square by sigma 1 square, r12 up to r1n, r12 1 up to r2n, then r1n, r2n up to 1. Okay, so what we have done is we have just split it into two determinants based on that first term. Oh, sorry, here it'll be 0. We have split it based on the first column. Sorry, here it will be 0. We have split it based on the first column, okay, and we have got like this. So now this first determinant is nothing but that omega, which we have already defined when we were doing plane of regression, okay, and the second determinant, if you expand using the first column, you will have sigma 1.23 up to n square, up to n square divided by sigma 1 square, and then this term here, okay, if you expand using the first column, this term here is nothing but omega 1, okay, and the rest will be 0 because the other terms of the first column are 0. So finally you will have your variance of the residual, okay, to be equal to sigma 1 square omega divided by omega 1. Okay, So this is the required variance of the residual of x1 on x2, x3 up to xn. Suppose you have only x1, x2, x3, then your variance x1 dot 23 will just simply be sigma 1 square omega by omega 1 1 only. Okay, I hope this is clear. And please practice again those properties and this derivation of the variance of the residuals by yourself. It is not hard at all.